Hello everyone, in my last video I discussed one problem statement on time series. Today I'd like to share the solution with you guys and I'd like to get the feedback from you guys. Okay, let me open the Word file where I have written the problem statement. Okay, this is not the one I'm looking for. Yeah, this one. So in my last video I discussed on this problem statement, right? So today I'm going to tell you the solutions for this problem statement. So there are two solutions I have identified for this problem statement. The first one is z-score. So in z-score you can take each and every points from the data set and subtract it from the mean value and divide it by the standard deviation. And once you get the value, then you can set the threshold and compare two graphs. Z-score value ranges from third standard deviation positive standard deviation to negative standard deviation third. And if your data set is not normally distributed, then this score will not work in that case. So in that case you can use Pearson correlation. I know Pearson correlation checks the linearity between two variables, linear relationship between two variables. But in that case we can use Pearson correlation and solve the problem. I would like to discuss with you how we can use Pearson correlation. Alright, first take okay, so in my last video I discussed, right? So one day data points means we are assuming 288 data points and 1 hour means 12, right? And if we take 30 minutes data, half an hour data, which means 6 data points. So if you check these 6 data points, let me take a pen. If you see the 30 minutes data, which you'll get a line, right? So you can take 6 data points and perform Pearson correlation. In that case you will get 6 p-value, right? And you will get these two lines are like if increase, it's a increasing, like positive correlation. If x is increases y also increases. If if x increases then y increases. So in Pearson correlation we find out the coefficient, like the covariance of xy, and we divide it by standard deviation, right? So the covariance means we measures the relationship between two variables. So if two variables are x and y, and if x tends to be increased or decreased, then y should increase and decrease, right? So that is called the positive correlation. So we can use these Pearson correlation for half an hour data and check the p-value. So if the p-value greater than 0.5, which means that we fail to reject the null hypothesis. And in Pearson correlation, the null hypothesis is two variables are totally independent, and alternative hypothesis says that two variables are dependent to each other. So if we take the point from 1 a.m., we will find out that if you see these 1 a.m., so the graph, the these points are like increasing, and on the other hand, if you check this graph, there is a straight line. So the x variable is increasing, but the y is just it is not increasing. There is a sudden drop also. So in that case, we will not get any correlation between two variables, so they are totally independent to each other. We will get a p-value greater than 0.05. so this is how, if we get consecutive p-value greater than 0.05, then you can say that okay, these are independent variables x and y, therefore there is no relationship between these two variables, which means that in between this time, like 1 to 3, there is no there is no relationship between x and y, therefore there is the two behaviors are different, and if it is normal behavior, then we can say this is not normal. So this is how you can solve this problem. And if you like my idea, then give me a thumbs up, and if you would like to give your feedback, you can put it in the comment section. I will in my next video I'll show you, I have not decided yet what I'll show you, we'll decide later. Till then, take care, bye, good night.